Hello friend, welcome to my channel. In today's session, we will explore functional interface in Java, their significance and practical applications. If you are looking to take your functional programming skill to the next level in Java, you are in the right place. Let's get started. A functional interface in Java is an interface with exactly one abstract method. This concept was introduced in Java 8 to facilitate functional programming and to support Lambda expressions. With a single abstract method, functional interface allow you to represent a function as an object, providing a neat and concise way to encapsulate behaviors. Take a look at these code snippets. Here we define functional interface named myFunctionalInterface with one abstract method execute. Notice how using a functional interface focus on defining the behavior without worrying about implementation detail. Why functional interface matter? Why are functional interfaces such a big deal in modern Java development? Well, for one, they bring cleaner, more expressive way to code. Functional interface allow us to write fewer lines of code by eliminating verbose anonymous classes. Let's compare a traditional anonymous class implementation with a lambda expression. As you see in the code snippets, how the lambda expression reduces the amount of boilerplate code while still achieving the same functionality. This simplicity is what makes functional interfaces powerful. Moreover, functional programming encourages practices such as immutability and side effect free functions, which lead to better parallelism in multi-threaded environments. That's why you will find functional interfaces extensively used in the Stream API, concurrency utilities, and event handling frameworks. Key features of functional interfaces. Let's dive deeper into the characteristics of functional interfaces. They adhere to the single abstract method principle, making them ideal candidate for lambda expressions. While functional interface must have exactly one abstract method, it can also include multiple default and static methods, adding more flexibility to how interfaces can be structured. Although the @functional interface annotation is optional, using it is a good practice because it conveys your intention and helps catch error during compilations. The role of lambda expressions. Lambda expressions are the gateway to functional programming in Java. They allow us to represent instances of functional interface in a clean and concise manner. The syntax for a lambda expression is quite simple, as you seen in this slide. Let's see an example where we use lambda expression to implement execute method of our my functional interface. Notice how we achieve the same functionality with just a single line of code. Before Java 8, implementing a comparator would typically involve writing an anonymous class. With lambda expressions, we can achieve the same result more elegantly, as you can see in this comparison. This not only reduces boilerplate code but also makes the code more readable. Understanding key functional interfaces in Java. Java 8 introduced several built-in functional interfaces to facilitate functional programming. This includes predicate, function, consumer, and supplier, each serving a different purpose. Let's look at some example. The predicate interface takes a value and returns a boolean, which is useful for filtering data. The function interface takes one argument and returns a result, making it perfect for transformations. Consumer accepts a value and performs some operation on it without returning any result, whereas supplier provides a value without taking any arguments. These functional interfaces are designed to work seamlessly with the Stream API, making operations like filtering, mapping, and reducing much more intuitive. Please wait for my next deep dive videos on these key functional interfaces. So till now, enjoy the rest of the video part. Now that we have covered the fundamentals, let's explore some real world applications of functional interfaces. One of the most common areas is the Stream API. Here, functional interfaces such as predicate and function drive stream operations like filter, map, and collect. Let's look at an example where we use a predicate to filter a list of names that start with letter A. In concurrency, functional interfaces play a crucial role as well. For instance, runnable is a functional interface used to run tasks in separate threads. With lambda expressions, we can write concurrent code more concisely, making multi-threading easier to manage. Event handling is another area where functional interfaces shine, particularly in user interface framework like JavaFX and Swing. best practices and common pitfalls. When working with functional interfaces, there are some best practices to keep in mind. First, always use the @functional interface annotation to explicitly declare your intent. This helps catch potential errors early during compilation. It is also important to use lambdas for simple operations. When a lambda becomes too complex, consider using a method reference or a separate method for better readability. Speaking of method reference, here is an example comparing a lambda expression with a method references. As you can see, using a method reference makes the code cleaner without sacrificing clarity. However, watch out for common pitfalls. For instance, avoid modifying collection inside lambda expressions, as this can lead to unexpected behavior like concurrent modification exception. Always aim for side effect free lambdas to ensure better code quality. Let's delve into some advanced topics. Higher order functions and functional comparison. In Java, functions can be passed as argument or returned as results, making them higher order functions. For example, we can compose functions using the and then method or compose methods to create complex behavior out of simple functions. In this example, we first multiply a number by 2 and then add 3, all within a single composed function. Covering another advanced concept involve breaking down a function that takes multiple arguments into a series of functions that each take a single argument. This technique is particularly useful for create more modular and reusable code. To wrap up, functional interfaces have brought functional programming to Java, allowing developers to write cleaner, more maintainable and expressive code. With features like the Stream API, Lambda expression and method references, Java has become a lot more versatile. Now I am ending up with this session. If you really enjoyed this deep dive, then don't forget to like, subscribe and share this video with your fellow developers. Stay tuned for more content on advanced Java programming techniques. Thanks for watching. I will see you in the next video. Thank you so much.